Hello everybody, my name is Alex Dahl. I am a mineral grinding specialist and the principal behind the sagmilling.com website. This video is a walkthrough of the sagmilling.com circuit modeling tools in the context of a new circuit design for a 43101 report. We'll be using published data for the Alacer Gold Gediktepe project prepared by Orwin Mining Consultants. Full disclosure, I have not worked on this project and I am not associated with either Alacer or Orwin. This project is being used because it has a good 43101 report that is available for the public to download from the cdar.com web portal. A design project in sagmilling.com consists of three components: a database of grindability testing from a laboratory, a set of circuit models for the potential grinding circuit designs, and a table of results where all available grindability samples are passed through a circuit model, generating a set of variability simulation results. Section 13 of the 43101 report describes 32 grindability samples that were tested. The tests performed include the bond work index for ball milling and rod milling, the bond low energy crushing work index tests, and the SMC drop weight tests. These test results have been manually entered into the grindability database for this demonstration. The Gediktepe model has been set up for the circuit design that is shown in the 43101 report. And this is a single stage sag mill that is in closed circuit with a hydrocyclone. The models that are available to simulate this sort of a circuit are a bond Barrett model that uses bond work index numbers, an El Soldado SGI model which uses values like the sag grindability index or SPI, and a Morel MI model that uses results from an SMC test and a bond ball mill work index test. So we're going to set the bond model for the first example here. The database contains grindability results for crushing, rod milling, and ball milling for a few samples on the project. And if we load, for example, this sulfide number 4 in, that's what these three work index numbers are representing, sample number 4. The model has a power draw generated for the grinding mill that is expressed in the 43101 report. And combining the power draw with the specific energy consumption, the model predicts what the throughput will be of this particular sample through this particular mill configuration. We can run all of the samples that are in the database through this mill, and it turns out we've got 5 samples, but we can see all 5 of them, and you get a range of throughput going from the hardest sample to the softest sample that are in the database. Because we have other test results in the database, we can switch the circuit to use the Morel MI model with the same F80 and P80. And what happens is that the grindability test results are no longer work index numbers, it's now MI numbers. So there's the MIA that comes from an SMC test, an MIC that also comes from an SMC test, and an MIB value which is generated based on some of the internal results of the bond ball mill work index test. So we have the same shell power because we have the same dimensions of the mill, and we have a set of throughput predictions for all of the test results that have an SMC test and a bond ball mill test. So you can see there's more samples available here than there was in the case of the bond model. The final thing I'll demonstrate today is the results table that you get when you run the models. We've got obviously a table here that you can see presented as a web page. We can sort by high tonnage to low tonnage or high hardness to low hardness. We can also apply filters on things like lithology if we've entered lithology, alteration regime if we've entered alteration regime. We haven't actually done that here, so you can't see these filters operating. And the last thing we've got is there's an automated report that's generated for these sets of simulations, and it's presented here as a PDF file. So you can manually dial in which of the percentiles of the database you want to see a little more details of. So when we press that button, we get a report in the form of a PDF, and it's got details of the 25th percentile sample, the 50th percentile sample, and 25th percentile sample. There's that same table we were just looking at when it was a web page, now presented in the PDF. And here's some of the details of the circuit settings so that when you're looking at the simulation results, you can see how it was configured. And then here's the 25th percentile sample, which happens to be the sample that's called disseminated. And it's got the MIB numbers, MIC numbers, and so on, and the throughput estimate. We've got information around the performance of the motor. I'll describe this diagram in a future video. It's used when you're doing the motor design to give yourself kind of the right amount of fat when you're doing the motor design. Here's the same again for the 50th percentile. Here's the details of the sag mill. Here's the filling levels, ball charge, speed that it's running at, and so on. And then finally, we've just got some cumulative diagrams showing the whole database in a graphical form. So here's the tons per hour of the samples that we've got in the database, tons per day. The transfer size, well, there isn't really a transfer size here because it's a single stage sag. P80, same thing. This is basically the same as a transfer size. And because this circuit is modeled in such a way, it always has a constant product size. There are ways you can set the model up to give you variable product sizes if you set something else to be fixed, but that's another future video. There's no ball mill, so this ball mill table is empty. And then finally the E total, that's your specific energy consumption for the total circuit, which of course in this case is just a sag mill. So there we go. That's the quick walkthrough. We have demonstrated an example project based on some published information. We've looked at the test work database, which is built right into the software. We've looked at some of the ways we can model circuits and the sorts of outputs we can generate. One thing before I forget, of course, we're all engineers here. Very important, we have the ability to output a spreadsheet here. So this table that you're looking at will be generated as a spreadsheet, which you just download and you can work with at your leisure. So that's it for this video. Thanks for watching, and I hope to see you in a future video.